Okay, those are the three criteria that the passenger could have regarding the routes. So, how to find solution to this problem? Can we come up with the solution for this? There are several solutions to this problem. First, the passenger can look at the airline route map and trace to each path to find out a successful route. But it is not easy to find all possible paths to the destination. The second solution for this problem can be simulate the human's way of finding a solution using computer programs. Yes, we can. We can use artificial intelligence for this problem. This is a far more better solution to solve this kind of problem. So, in artificial intelligence, as we described early section of this video series, we need to provide all necessary details and ask the program to come up with the best solution for the problem. So, to implement the artificial intelligence, we use Alright, first of all, before going for the solution, we have to model the problem in a way which will more easier to solve. So, what kind of modeling methods can we use? That's where the good old graph theory coming very useful. We can model the airline route map as a graph. In that graph, we can denote airports as nodes and airline route as edge. But the fact doesn't imply the both direction. So what we can do? We can duplicate the fact for its reverse meaning. But if we define facts like this, the number of facts will be doubled, making the size of the Prolog database twice the size. What we do for avoid this problem? Prolog is providing a smarter way to solve this kind of problems. We can simply define a route to overcome this problem. Let's create a Prolog rule like this. This rule implies the two airports X and Y are connected only if X is adjacent to Y or Y is adjacent to X. The semicolon denotes or here. Now the Prolog application must know the routes from one airport to another. There should be some way for Prolog to determine a route between airports. For this purpose, we shall create another rule called route. This rule will determine the routes between two airports. To create this rule, we must have a logic in Prolog. So we can use recursion theory to understand the logic. So here is the logic. A route from airport A to B is obtained provided that A is connected to some other airport X, and a route can be found airport X So we can map this rule in Prolog like this. Now let's decompose and try to understand what this rule says. Implies that a route from airport A to airport B is exits if and only if some condition on right side are met. Here the route is there to save the route from A to B. So we use Prolog list to represent the rule. It implies A is connected to some other airport called X. Here the comma represents the logical AND. Recursively check whether a route exists from some airport X to airport B, which is our destination. So here we are. We have come up with Prolog solution to find routes between two given